Hey guys, happy Tuesday. We are in week 5 of the logarithm unit. Monday, the goal was to check part 1 and part 2 homework, but I didn't publish that until like 7 p.m. on Monday. My bad. So hopefully you have done that at some point. You can just go back and check and see how you did. We're going to do 10.5 part 3, which is laws of logarithms again. We're just solving full equations this time, so you'll see what I mean there. I'm going to do 3 problems for you, and you guys have to do the rest. And then Thursday and Friday, we're switching it up a little bit, but I'll talk about that after the lesson. Okay, so I'm going to be doing 33, 39, 47. Here is 33. So I want, magenta, my usual. Okay, so right now I have 3 logs, and I have 1 log is set equal to 2. So we're going to use our laws of logarithms. I see I have this coefficient. I know coefficient, when I bring it back into log form, is an exponent, so I'm going to do that first. So I still have log of a of x, and then the only thing that's changed is instead of having the 2 out here, we now have the 2 as an exponent. So we're going to keep going and we're going to simplify. We know 3 to the second power is 9. And then when there's addition between logs, remember that actually means that we multiply those 2 guys together. So we're going to end up with log base a of x is equal to log base a of 45. And so these are the same. We have log base a. We have log base a. They have the same base. So that means that these guys should also be the same. So we have actually solved the equation. We know that x is 45. That's it. So these problems aren't bad. The bases are all the same, or like it's the same kind of log. So you can go ahead and use the properties to combine and smush together. Same thing here. They all are log of b. Here, they're all log of a. But you'll notice on 39, we have log of 2 is equal to not log of 2. So let's talk about 39. Okay, so 39, I have log of 2. I have log of 2 is equal to not log of 2. So I can't do anything to this equation until 4 becomes log of 2. So it needs to become log of 2 of something, okay? So how we figure that out is we know we have to have log of 2. We don't know what x is going to be, but we know it has to equal 4. This is our exponent. This is the exponent. This is the exponent. So we have to take this guy, and we're going to rewrite it in exponential form. So we know 2 to the 4th is equal to x, and so we know that 2 to the 4th is 16. So we know that 4, if I'm needing a log with a base of 2, this has to be 16. So what I'm about to do is replace 4 with this, because then I have log base 2, log base 2. Let me show you what I mean. So what I've done is that instead of log base 2 equals 4, I now have log base 2, same thing, is equal to, not 4 anymore, log base 2 of 16. Now that they're both log base 2, I can set these two things equal to each other, and we can go ahead and solve. So the first step is we're going to add 9 to both sides, and we get x squared equals 25. And then we're going to square root both sides, and x is equal to not 5 plus or minus 5. This guy has 2 answers. 5 works and negative 5 works. So that's where these get tricky, is if they don't have all the same logs, you have to create the same logs. So that's where those problems get hard. Last problem. So another one where, because I just thought it'd be helpful to see twice, this is log base 6, this is log base 6. Yikes, this is not log base 6. So if you remember, if we have 1 means that the base and this are exactly the same. So I'm just going to replace 1 with log base 6 of 6, because log base 6 of 6 is 1. It's that little trick that I tried to tell you to remember because it would come in handy later. Here's later. Okay, so now I want to use my laws of logs. I know that if I have 2 logs that are being added together, that means I'm actually multiplying these 2 guys. So I'm going to smush them together. And we have log base 6 of x times x plus 1, or x plus 1 times x, whatever you want. And it's still equal to log base 6 of 6. Nothing crazy's happened. I'm now going to go ahead and distribute this to both. So now I have log base 6 of x squared plus x is equal to log base 6 of 6. So now I have 2 logs mushed together. This is log base 6, this is log base 6. So I know that these have to be the same. So I'm going to go ahead and set them equal to each other. In order to solve this, we have to get it equal to 0. So we're going to subtract 6 from both sides. I guess I should have shown that step, but I feel like we've done this like a zillion times. Okay, so I subtracted 6 from both sides. That's where this came from. I got it equal to 0. So now we're going to factor. I didn't show work. I just did it. You get x plus 3. You get x minus 2. So that means x is equal to -3 and positive 2. The only thing that's tricky is you have to plug these back into the original equation sometimes not. And actually -3 does not work when you plug it back in. So if you want to take the time to plug in -3 and then to plug in 2 to see why -3 doesn't work and why 2 does work, I would encourage it. That is it for today. These are the rest of the problems you have to do. What is that? 10 problems? 9 problems? That's not bad. Hopefully you guys get on conferences. It's been pretty boring. But if not, that's totally fine. You guys are super capable and this must be really easy. So I'll just see you when I see you.